Hi there, my name is Sarah Wilson and welcome to my video on trigonometry for statics. Trigonometry is the study of the ratios of the side lengths in a right triangle. And so that's what we have up here. This is a right triangle and you can tell because of the box marking in the corner that shows 90 degrees. And to start off with, I'll define the three most common ratios that are used in trigonometry. That would be the sine, the cosine, and the tangent. Now in this triangle right here, I'm going to start by marking the angle that we're going to label everything relative to. In this one, since we're just defining, I'll just pick a random angle like this one down here at the bottom. I'm going to label it theta. Now theta is just a variable, like an x or a y, but it's a Greek letter and it's most commonly used for angles. So we're going to stick with theta, but you could just use an x or a y if you like. Compared to this angle right here, the three sides in this triangle need labeled. In the right triangle, the first side that I always label is the side that's the longest. It's right across from the right angle. So if you come straight out of the right angle, the side that you hit is called the hypotenuse. And again, compared to the angle that we're going to focus on here, if you think about coming straight out of that angle, I almost imagine being shot out of a cannon. Pew! If you come out of that angle, the side that you hit then is called the opposite side. And then the last side, the one that we haven't labeled yet, is called the adjacent side. It's right next to the angle that we're going to be working with. So the first step in doing any trig problem is to label the three sides relative to the angle that you want to work with. And like I said before, the three ratios that we're looking at are the sine, the cosine, and the tangent. Sine is abbreviated SIN, and you probably have seen the button on your calculator. And the definition of it, the equation that you get with sine, is the sine of theta equals the ratio of the opposite side to the hypotenuse. So if you had this side length and this side length, you'd put them in a fraction together with the opposite on the top and the hypotenuse on the bottom. The cosine is the next trig ratio we're going to look at, and it's abbreviated COS. And the cosine equation looks like the cosine of theta equals the ratio of the adjacent side to the hypotenuse. So again, in this one, adjacent is on the top, and hypotenuse is on the bottom, down to the denominator. And then the third one that we're going to take a look at is the tangent. And the tangent is abbreviated just TAN. And the equation that goes with tangent is the tangent of theta equals the opposite over the adjacent. So this one, hypotenuse, doesn't have a roll in. It's the other two legs of the triangle with opposite on the top. Opposite in the numerator, adjacent in the denominator. And those are the three trig ratios, and you've probably heard the mnemonic device to help you remember those. It's one of the more famous ones. This would be SOHCAHTOA. And let's see, we'll put it right up here so that you can see it. S-O-H for sine, opposite hypotenuse. CA, C-A-H for cosine, adjacent hypotenuse. And then TOA for tangent, opposite, adjacent. So SOHCAHTOA, if you've ever heard people using that mnemonic device, that's what they're talking about, to help you remember which trig ratio goes with which ratio. Alright, so let's take a look at an example of how you would use one of these trig ratios. I have a triangle up here that I've labeled some information in. I've got a 50-degree angle marked. One of the sides is 6 meters long, and then the other side would be the one that we don't know that we're trying to find out. So here's how you go about a problem like this. Start by taking a look and labeling the sides relative to the angle that you're given. So in this case, it's the 50-degree angle. Alright, just like we did before, let's label which side's the adjacent, what side's the hypotenuse, and etc., etc. First off, I almost always label hypotenuse first. So straight across from the right angle is the hypotenuse. So imagine coming straight out of it, there it is. Alright, next off, look at the angle that we're given and imagine shooting out of a cannon at it. It lands over here, and this side is the opposite. then the remaining side, the one that hasn't been labeled yet, is the adjacent. Okay, 3 sides are labeled. And now you take a look at the information that you're given and the information that you want to find out and decide which trig ratio goes with it. I know an adjacent side. I'm looking for the opposite side. So up here, adjacent and opposite, which trig ratio includes adjacent and opposite? That would be tangent. So that's how you know that's the trig ratio you want to use. I'll write myself the tangent of theta is the opposite over adjacent. And now fill in the information that you know. Theta, remember, is just the label for the angle, or it's a variable for the angle, so we're going to put 50 in where there's theta. So the tangent of 50 degrees equals the opposite side, and that's the one we label up here, that's the x. We don't know it, so I'll just put in an x for it. And then adjacent is in the denominator. So that's over here, that was that 6 meters, that goes on the bottom. And now it's just a little algebra problem, and you have to solve to get x by itself. Since we're dividing here, you have to do the opposite of dividing by 6 meters, which would be multiplying both sides by 6 meters, and that's how you'll get it to cancel off. So these two are opposites, they're gone. And now all I've got left is x on the right side, and 6 times the tangent of 50 over here. Sorry, 50 degrees. Now in your calculator, you're just going to enter this exactly as it looks right now. 6 times the tangent of 50. Let's see what we get. One thing I will point out to you is that if you haven't used your calculator for a while, or if it's a brand new one, you'll want to double check and see what measurement your calculator is in. There are a couple ways you can measure angles. Degrees is pretty common, but also radians is another one. And so if your calculator is currently in radians, you want to make sure that you switch it over to degrees so that you're getting the correct answer. So when I type it in here, I get about 7.15. I'll go ahead and round to the nearest hundredth. And that's 7.15 meters. We're in meters for this problem. And what we just found is the length of this side right here. So this side over on this side is about 7.15 meters long. And let's do one more example. Over here I have another right triangle. This time I have labeled 18 degrees. I've got 9 feet down at the bottom, and up at the top is the angle that, the side length that I'm looking for, z up there. And let's label just like we did last time. Alright, first off, hypotenuse. That's always across from the right angle. There it is. HYP for hypotenuse. And then here's the angle we're working with. It comes straight out of that angle. The side that you run into is the opposite side. And then the last side that hasn't been labeled yet is the adjacent. Alright, again, let's take a look at the information that you have and what you're looking for. We've got adjacent and hypotenuse. Adjacent is the one I'm given, hypotenuse is what I'm looking for. So let's look back at SOHCAHTOA. Adjacent and hypotenuse looks like a C, which is cosine. So I'm going to use the cosine equation to solve this problem. Okay, let's fill in the information that we know. Cosine of theta. Angle that I have that I'm working with is 18. So I'll put in the cosine of 18 degrees equals the adjacent side, which is 9 feet, over the hypotenuse, which is z. That's the variable that I'm looking for. Now, it's an algebra problem just like last time, but watch out, because z is what we're trying to get by itself. And you can't just divide by 9 here, because 9 isn't being divided, z isn't being divided by 9. So you have to take one extra step compared to last time. Let's multiply both sides by z. And what that'll do is cancel it off the right side. And it'll be over here on the left. It'll say z times the cosine of 18 degrees equals 9 feet. And now, to finish getting z by itself, notice it's being multiplied by the cosine of 18 degrees. Opposite of multiply is divide. So we'll divide both sides by the cosine of 18 degrees. These two should cancel each other off. I'll be left with z equals, let's see what that comes out to be, 9 divided by the cosine of 18. I get 9.46, rounded again to the nearest hundredth, just because I like hundredths. And we're in feet. So 9.46 feet would be the length of the hypotenuse in this triangle. In all the problems we've looked at so far, I've given you two pieces of information about the triangle, one angle and one side. But what happens if you're given two sides of the triangle and you're trying to find the angle instead? Well, the nice thing is trigonometry can still be used to find that piece of missing information. And let me show you how. In example 3 here, let's start off the same way we did with our last couple problems. We want to label the information we have and see what information we're trying to find out. In here I've got theta. But notice this time I just left it as theta. I didn't actually tell you what the angle measure is. But I can still label the sides in relation to theta. Again, starting with your right angle, straight across from it is the hypotenuse. Coming straight out of the angle that we're working with, the side that you hit there is the opposite. And then our remaining side, the one that's not been labeled yet, is the adjacent. Alright, so let's see what information we have and what information we've got for that we're trying to look for, and pick our trig ratio. I've got a hypotenuse and an opposite side. So which trig ratio includes opposite and hypotenuse? That is sine. So let's write an equation with the sine. The sine of theta equals the opposite over hypotenuse. Alright, fill in the information you know. And unlike last time, since we don't know the angle, we'll just leave that theta in there. So the sine of theta equals the opposite side, which is 6 inches, over the hypotenuse, which is 10. Now here you see inches divided by inches. That means the units are going to cancel away. So inches and inches are gone. I'm left with the sine of theta equals 6 over 10. Now to get rid of the sine, lots of people want to just say, well, can I divide both sides by sine? But sine's not a number. It's more like an operation, really, is how you can think about it. And so to get rid of the sine, you have to use the inverse sine. And that's written as the sine with a little negative 1 up like an exponent. So this is the inverse sine, and I'm going to do that to both sides. Inverse sine of the sine of theta equals the inverse sine of 6 over 10. So here, what you've got is the inverse sine. I did that to both sides of the equation, keeping it balanced. And then here, the sine and the inverse sine cancel each other away. I'm left with theta equals the inverse sine of 6 over 10. And that's what you enter in your calculator. An inverse sine is usually found right above or right next to the regular sine. So let's take a look and see what that gives us. I've got the inverse sine of 6 divided by 10. And it comes out to 36.869, and so on and so on. So let's round to the nearest tenth. How about that? We'll take 36.9 degrees this time. So theta comes out to be degrees because we're measuring the angle. So we just find out that this angle right here is 36.9 degrees. Now you may have noticed as we're going through these that my drawings are not to scale. And that's true in any kind of geometry or trigonometry problem. You should always go by what the picture is labeled, not necessarily what it looks like. Let's do one more example. Example 4 over here. Where do we start? Labeling the sides, just like always. Coming straight out of the right angle, we hit the hypotenuse. Coming straight out of the angle that we're working with, we hit the opposite. And then our remaining side is the adjacent. And this time, I've got adjacent and the hypotenuse are the two sides that I have. So which trig ratio should I choose? Adjacent and hypotenuse is cosine. So let's write an equation with cosine. The cosine of theta equals the adjacent. Let's just do it like this first. Adjacent over hypotenuse. So I always like to start with the formula and then we'll substitute in. So cosine of theta is adjacent 8 centimeters over the hypotenuse, which is 9 centimeters. And there again, you can notice that our units are going to cancel each other out. Centimeters and centimeters. And just like before, to get rid of cosine, you have to do the inverse. So I have the inverse cosine of both sides. So cosine, 1, and then the inverse cosine for here as well. These these should cancel each other out just like before. I'm left with theta equals the inverse cosine of 8/9. And then it's just a matter of a calculator. So inverse cosine of 8/9 comes out to be 27.266. Let's round to the nearest tenth again, so 27.3. And again, that's in degrees. So that would be the measure of this angle up here at the top, 27.3 degrees.